Okay, so the next topic is chunking, and we will try to understand why do we need to do chunking and what is the advantages of chunking in a RAG system. So first of all, why do we have to chunk documents, right? Um, the fundamental reason is token limits. What is token limits is, let's say at the end of the day, the documents that you retrieve from your vector database, you append to your prompt and you send it to a LLM. Let's imagine you don't do chunking and you send a 1,000-page document to the LLM, which means you have, I don't know, 10,000 words in that 1,000-page document or 1 million words, and so much of words will convert to so much of tokens, which means it is a very expensive LLM query. So you don't want to dump an entire document to the LLM, and it can still hallucinate because it has to still figure out where exactly is the answer to your question. Let's say the question is when was the city Bangalore renamed to the name Bengaluru, right? So if you pass a 1,000-page document to it and you tell them figure out what's the whole point of doing a RAG system itself, right? So yeah, that's one reason why we do chunking. Improved relevancy. Okay, let's say you divide this 1,000-page document into one page chunk each, and then in your RAG query you pass the exact I don't know 550th document which contains the answer to this question. When was the name Bangalore changed from Bangalore to Bengaluru? Then it is easy for the LLM to just search through, I don't know, 100 characters of this one page data, and then it can quickly answer, and the number of tokens will be less, and it has the very relevant information. Um, yeah, and then the final reason is okay, if you do small chunks, then you only send very relevant information to it. It doesn't have to then figure out which information on from this whole data is further relevant or refine it. So this is why we never index entire documents in the vector database. We always perform chunking, which is basically dividing the whole document into sub chunks, and maybe think of it like one paragraph is embedded, or maybe one sentence, or maybe two paragraphs. And there are different strategies, chunking strategies, which we will discuss. So the first strategy is fixed size chunking. You take a document and you say, okay, I'll do a fixed size chunking, 250 characters per chunk. So once 250 characters are done, you split that, you send that chunk to the vector database for embedding, and then you start with next. So let's say 1,000-page document, 250 characters means maybe per page you will probably get four chunks, let's say, which means you have 4,000 chunks for that 1,000-page document. Okay, now it could happen that if you cut between characters, right, so the meaning might not be complete, or it might happen that certain meaning get missed if you end up with 250 characters in the middle of the sentence, right? This is actually not so nice because even the sentence might not have completed. So what you do is you do some overlapping so that the meaning is carry forwarded. So instead of doing 100 to 250, you start the next one with 225, which is like you carry over some 25 characters from previous chunk, so that there is some overlap, so that if some meaning is missed for this chunk, you get some meaning back. That is the second strategy. Okay, then the next strategy is splitting based on new line character. So let's say every sentence you end with a new line, or so. Oh, it's not new line. Okay, so paragraph, right? So if you want to do a new paragraph, you enter a new line, which means there is a gap between the first paragraph and next paragraph. And for every new line, you do a chunking. So now you can imagine every paragraph will have its own chunk. So this is also quite an interesting strategy where you avoid this problem of chunking between sentences. Because if you say 250 characters, it will most probably end in some part of, I don't know, in between the sentence. And this is not nice because the meaning is lost. Maybe for text this is interesting, but what about other types of documents, right? HTML documents, some Python code. So here you can use different strategies like, I don't know, start of every function, start of every class. So every class will have its own chunk, every function will have its own chunk. And I don't know HTML, but I don't know, it seems like HTML also has some kind of a start of character, end of character, stuff like this. So you can choose different
Right.
strategies for different documents.
HTML.
So, okay, what are other problems that we will encounter during chunking is what happens is the meaning of a sentence might be different if the sentence is not read fully. So let's imagine there is this sentence: that night she dreamed, as she did often, that she was finally an Olympic champion, right? So let's say in our chunking strategy, this all orange or I don't know beige colored sentence was one chunk, and then this green colored chunk was another chunk. And then if you ask the question, did she finally become an Olympic champion? And finally, then we will get the answer, yeah, yeah, she finally became an Olympic champion. But the reality is that she was still dreaming to become an Olympic champion, right? So this is a huge problem. When it comes to checking strategy, if you used a very fixed strategy and it happens that somehow mid the sentence it cuts, or even between sentences also the meaning can be interpreted differently if they are split into different chunks. So one strategy to solve this problem is semantic chunking, right? So what happens in semantic chunking is what you do is for every sentence you calculate its meaning, and for the next sentence you try to figure out if the meaning of the next sentence is relevant to the previous sentence or it is very different from it. So let's say, okay, Canada is known for its maple syrup. The country has a beautiful mountains. Canadian landscapes are stunning. So now both these sentences are talking about the same thing, which is Canada, because you see, okay, landscapes, country. So it's all talking about the country, right? And it's talking about, I don't know, some characteristics of the country and stuff like this. Let's say after this paragraph, it starts talking about, I don't know, GDP of it, right? Okay, GDP is now a completely different topic, even though it's related to country. Previously, it was something related to, I don't know, a tourist might be interested in, right? So, what is nice about Canada? What places? What is nice to see? Mountains are nice to see. Landscapes are nice to see. So, a tourist might think or might want this information. But let's say the next paragraph starts talking about the GDP of Canada. This is probably not interesting to a tourist, right? So the meaning here now changes completely. So what semantic chunking will do is it will chunk similar meaning sentences together in one chunk, and once it realizes that the meaning has now changed substantially, it will chunk it into a different section then. So this is one more strategy of chunking. Okay, disadvantage here is it is a bit time consuming strategy because every sentence has to be vectorized. Its vector meaning has to be computed and then compared with the previous sentences or the previous sentences that were forming a group. Now, if you have to do this every time for chunking, it will obviously take a lot of time, and this is one major disadvantage here. Okay, one more idea here is instead of doing a semantic based meaning, you just give the document to a LLM and tell the LLM, boss, read the document and then decide which chunks belong together and which not. So, and LLM is also already smart, right? It knows language very well. So, language is very good expertise of a LLM. So, the LLM can do it chunking for us. Again, the performance here is very good, but then again, it's a huge cost, right? Because LLM queries are costly and also time consuming. So again, so the performance is better later on, but if you have to use this strategy, it is a bit expensive and slow. Um, Okay, and the final strategy or one more strategy is context aware chunking. So what you do is you ask the LLM to enrich the metadata of this chunk by providing a summary of the chunk. So let's say there were certain chunks, and then you ask the LLM, what is this chunk talking about? What is the meaning of it? And then what is the context? What is the summary and stuff like this, right? So this gives additional context to this chunk, and you attach this additional information in the metadata. And then this is helpful because then you can do metadata based filtering, and you can use that enriched information for doing improved comparisons. Or you can also embed this context into a vector database, and then you can associate it with the original chunk. And when you do an actual search, because you have a summary, it's easier to point out to the right chunk where that particular information is. Again, this is very complex, but this is a strategy that is actually being used in the production environments, where when you have a huge chunk, having a summary for the chunk gives a big advantage that you already know what exactly you are looking for in the summary. And this is context aware chunking is a strategy that is adopted in the production environment, at least in the project that I'm working for, uses this strategy. So just to give a summary of this whole entire chunking, maybe I'll just give you what kind of a combination that we are doing. What we do is we use fundamentally a fixed size chunking strategy where we have 1,500 character length, but we don't break mid sentence. Once you have 1,500 characters, you don't break immediately. What we do is we try to wait until the end of the sentence. So we wait for the full stop character so that we are sure that that sentence ends. And once the sentence ends, the next chunk is started. So we use a fixed chunking strategy because it is fastest, because it is, you can write a nice Python code for it. You say you start counting the characters, and then once you have I don't know, 1,500 characters, you wait until the character full stop and then you chunk it. We don't do overlapping in our work or in our project. We skip overlapping, and we use this context aware chunking also. Once we have the chunk, what we do is we send that chunk to a LLM, and we ask the LLM to summarize it and enrich it with additional metadata. And we store this enriched information in the metadata related to the chunk. So when we do a hybrid search, through this metadata search, we actually get much more better results. Yeah, so this is currently what we are doing. So this is the entire story of chunking. And yeah.